located in Virginia or Canada?
No. We're actually about a mile from here. Yeah. We have lots of Canadian customers.
Sorry, Bill.
In fact, the original CRC system was all based on. It ended up at Nordiasoft and then now the Avi. So it's just a little background. So we have two groups in the company. We have a middleware group, which does real-time embedded systems. Most of this is about that. We support 6,000 computing platforms. We're trying to kill them every day. Every time we try to kill a platform. So a platform to us is a combination of a language and a compiler version and a CPU architecture, ARM 9 versus ARM 11, operating system, right? So, and we support, 12 operating systems. It's a lot. And we get involved in, we've been through D178B certifications multiple times on our software. We've been through two full, OrbExpress has been through two full security evaluations, fully funded security evaluations where we did a lot of pen testing and enormous amounts of static verification. And we are so committed to industry standards that people can replace our product in a couple of days. And we're actually proud of that. They can also replace other products. We had somebody who developed a radio, and they won't let us say who they are, but they developed a radio with open source product, and they were having a lot of problems, and they switched to our product, and it took them about 4 days, and then they kept wondering why the radio was dying in 10 minutes because it had an eval copy.
Eval copy, that's right.
Yeah.
Didn't actually pay for realizing.
Okay, so DevSecOps. Let's talk about a couple of things in DevSecOps. Number one, where did it come from? Well, DevOps is the application of software methodologies to the system development lifecycle, right? I mean, we've been doing this in software development for many decades. Configuration management systems, branch and merge, those sorts of things. And branch and merge of a virtual machine is a little tricky. We haven't quite figured out that yet, but a lot of the tools are trying. And so a lot of cool tools were born to record and replay system configuration, versioning, isolate services, the containerization, etc. Problem is, a lot of these cool tools bypass all the OS privileges and protections. I mean, you look at how much work Microsoft has done in their RSAT, Remote Systems Administration tools, right? Just so that they can talk, so that you can be on one virtual machine and actually, manage Hyper-V on another node. And there's a lot of work that goes into that. And it's not like they don't end up with some vulnerabilities occasionally in those processes, but the guys who develop cool tools aren't always worried about the security problem. So DevSecOps was initially an effort to lock down these insecure tools because they all run at privilege level, and it created this enormous surface area in the kernels for vulnerabilities in the systems. So the original DevSecOps was about trying to lock down these tools, but then it kind of grew into something else. Everybody got kind of a hold of it and took off with it. And if you look on cyber.mil, it has a nice discussion of DevSecOps, right? The US military has done a lot with this because they do a lot of systems and they suffer a lot of systems. So they have made a very organized plan for software lifecycle. So, planning, developing, building, testing, releasing, delivering, deploying, operating, monitoring, etc. So the philosophy of DevSecOps has become build security and test the system during all phases. And then stop building first and then securing later. It's like the old benchmark mentality, right? Historically, software engineers would develop software and they'd go, oh, where's the hotspots, and try to optimize it. And you couldn't really make the system very performant doing that because you'd kill the thing that was really stupid, and then you work on to the next stupid and kind of work your way through. you'd end up with something that if you developed it for performance in the first place, it would have been much faster. But the general objective is to compress the time to operational. When you've got an approved system that you can deploy and you can redeploy with incremental upgrades, not create such a long delay. So configure security early, right? And you want to take security into your thinking of your planning and your development, your building and your testing and your releasing and delivering and your operating and your monitoring. And that planning part's a really important one because a lot of people don't pay attention to that. They say, oh, we'll do it later, right? If you let the engineers do it, they're going to do it later, right? Because security's just not a lot of fun. And it's, you know, you can scan your stuff. Like, imagine that you're going to write a new piece of software and you buy a really cool, good static code analyzer. And when the engineer writes the very first hello world program, you say, oh, you got to run it through static analyzer. But I've only written 10 lines of code. What are you bugging me for? Well, because let's say if the 10 lines of code is broken. It'd be a lot easier than when you have 400,000 lines of code. So the DevOps system tools, these really cool tools that really are a lot of fun to use, well, they sometimes hurt. They got a lot of vulnerabilities in them. And I threw Python on this chart because a lot of them are built in Python. And Python itself has a lot of vulnerabilities. The duck typing in particular causes magical things to occur when it tries to analyze a type change and make changes to the system. So you have to be careful when you use these really flexible tools that you're not injecting very low quality code. And I'm not saying these tools are low quality. But you're introducing new vulnerabilities that may not have been fully pen tested and evaluated to be given that level of privilege. Because guess what? I mean, you know, your scanners, right? You know, things that just go around and do port scans and configuration scans like Nessus or OpenSCAP or things like that. They get all your privileged stuff, right? They get all your privileged accounts. Everything you do, the keys to the kingdom are put into these tools. Yeah, so I mean, I have some folks I know who the CEO asked me to come over and actually do a security review with one of their with their engineering team, and they were doing this cloud thing and you know, trying to manage people's both on-prem and off-prem systems remotely. You know, cell phones, things like that. And I said, where are you going to store all the passwords? And I said, well, on a server. Which server? Which server do I go get all the passwords for 2,000 customers? The administrative passwords for 2,000 customers. Which one is that? What's the IP address? Can you tell me what the IP is? Oh, okay, that's a bad idea. So I gave them some suggestions so that they would not have access into their customer's system. Because if you take network access vulnerabilities, okay, because you're now taking some things that may not have had network accessibility without huge amounts of evaluation, and you're giving it network access. So you're taking network accessible vulnerabilities plus insider threats and Bob's your uncle. So the only real constant here in these processes is change itself, right? So computing workloads, both desktop and server, are constantly evolving, and this isn't going to change. Some of the challenges is that, like virtualization is this wonderful thing, but if you look at some of the containerization technologies, they say on their websites, we didn't do this for security. We use some of the hardware features built into the chipsets for virtualization acceleration, but not all of them because we weren't trying to do security. This is so. Now security is becoming, it's slowly getting a better name for people to pay attention to it. So those might disappear off the websites, but the fundamental issue is we need to configure new hardware, software, firmware, and this all comes down to what's called cyber hygiene, right? This whole idea that we can configure our systems in security, right, is well, why were they configured insecure? And if you want to know who this presentation's for, it's for the vendors in the room. If you deliver systems that are configured properly in the first place, a lot of these issues don't become as important for your customers and for everybody else. For example, Microsoft about 3 years ago, suddenly in the Patch Tuesday, pushed out all of OpenSSH into Windows 10 and the Windows servers. So now Windows had SSH. It's cool. Yeah, but they didn't turn off DES. It suddenly failed all the scans, right? Because they hadn't chosen to configure the system. So everybody had to go into the system and configure the system so that it didn't have all the really old, stupid crypto protocols. Now, God love, the Linux is getting much better about locking down some of these protocols by default. And I get it. Nobody wants to break anything, right? Vendors hate to ship a new product that breaks everything, particularly the people who manage the support team. But at some point, you're either going to, if you don't force the breakage on your customer, then the customer is going to have to break it themselves. And then they're going to have to do all the research to figure out how to come out of the breakage, as opposed to you writing a new chapter in your doc. Okay? So rapid change requirements run counter to diligent change management. Right? We've written multiple change management documents for customer organizations. And change management's most software engineering teams are pretty good at change management. They use good change control mechanisms. It's a little tricky when you start checking VMs into Git. You put a 200 megabyte VM in, or gigabyte VM into Git. It doesn't like that very much. And then people replicate the repository and go, why is it taking 3 hours? But rapid change amplifies the need for continuous monitoring and response, because we're talking about trying to get to a level of correctness on systems. And change and correction, being correct, don't have to run counter to each other. They usually do. And that goes to testing, and modern software engineering teams will branch every change. I know in the org, some engineer about 20 years ago, tried to convince me that we need to branch every change we make. You want to reformat the code? It's a branch. And it took him 18 months to convince me of that. But he did, and he was right, and way right about it. And because you basically have to validate every change and run through the entire test suite before you merge back. And that's become the normal philosophy. And if you look at the most of the change management doctrine, it talks about that. It's a little tricky in a production, enterprise. How does Google do that for their cloud? They got a production cloud. They're gonna have a non-production cloud, or they can certainly do pieces of it. But it becomes, am I testing it with real data? It just gets rather complicated. But diligent testing requires isolation. That makes change management a little harder. Adversaries are always hungry for sloppy change procedures. That's what they live on. They're also happy with stagnation. You don't change, what have you. IT deployments are very challenging. IBM study shows 40% of IT projects meet schedule, budget, and quality goals. And there's lots of examples of this, of IT projects in particular have a very difficult time achieving their deployment objectives. Government IT deployments are way more challenging, right? Government systems tend to audit a lot more. Their IO infrastructures are taxed. A lot of times, you go search for some data and you end up writing enormous amounts of data because your auditing is crazy. So your SSDs, which are 2.5 times slower for writing data than they are for reading data, unless you get the technology that Intel's about to shut down. Optane in 3D Crosspoint is horribly expensive. The system slows down by a factor of 3 times. And if you design this system in the first place for this kind of workload, it's a lot easier. And it works better, but you have to over-engineer it. And government folks tend to pay people by the hour to set up their IT infrastructure. And that means that they, failure's a little less impactful on your supply chain because they make more. And it's not the intent, right? They're trying to make a correct system, but in the end result, it takes longer, they make more. So a lot of the COTS vendors won't take responsibility for real cyber hardening. That's the point of this presentation, right? Get the COTS vendors in the room to take responsibility for their products and what they're putting in and what runs at privilege level. Do you have to run at privilege level, right? Install Shield, if you use Install Shield, it wants you to escalate before you install, just so it can update the registry to put a list of files in there so it knows what to uninstall. That's the only reason, but you have to actually do that. Maybe you could put that file somewhere else. Maybe it doesn't actually have to go in the registry. And a lot of COTS vendors don't know how the products are actually built. A lot of times it's because they're so dependent on open source, right? They got, this is the turtle problem, right? They're turtles built on turtles and you don't know what's there. Bad scans means your schedule slips and slips and slips. And an economic model, I mentioned that, most organizations lack good organizational processes. And oddly, as a COTS vendor, you can actually solve the organizational problem. You can give the customer a process to use your product with your product. And it then makes the customer successful because they don't have to interpret how to do that. It goes to the questions that came up for Red Hat about, what the best practices are. A lot of times the COTS vendors know the technology the best. They're the ones who have the most analysis in technology, and they can share that. Successful IT deployments, right? So VDI is something that's gotten a bad name over the years. And it mainly becomes because your local IT departments are trying to do VDI deployments. They're not, and you get in this whole thing with the cloud as to who owns the system. Does the cloud company, the sponsor of the cloud company, own the system? Is that the party who owns the system and the security controls? Or is it what's inside the virtual machines? And what's the computational boundary between the virtual machine and the cloud? Where's it stand, right? There's a thing here, right? Good arguments happen between the people who approve the cloud and people who approve the virtual machines. And what is the security boundary of that? And where do we get our Red Hat updates and our Windows updates? And there's some stuff here. Solid funding and acquisition strategies, good people and processes, good technologies, good partnerships with users and vendors. This is all normal stuff. So, what's my parting recommendation? Use DevSecOps processes for designing in and maintaining security. They really are a fine thing, and DevSecOps is more of an organizational impact than a technical one. I know there's an industry built around trying to solve the system controls and the system part of the hybrid controls for DevSecOps. But it's the patterns of procedures, right? The design processes for the fundamental IT systems in the first place, the discussion of the models. That's a fine pattern. There are security, if you look at operating systems in general, there are certain pieces that get a lot of attention security-wise, and I don't mean to pick these out, and they certainly got lots of flaws. And there's NPR even had a nice article on how TPM 2.0s are now compromised about 2-3 days ago. So nothing's perfect. But there are parts that get a lot of security attention in these systems. And if you build your building blocks on those core pieces, they'll tend to get fixed quickly. if you make your security argument, right, your formal security argument dependent on everything, you're done. You know, yes, you have made convenient meeting all of the STIGs and the CSIs and all of the other stuff, but you haven't necessarily made your system more secure. So you got to layer your security argument, and part of that involves minimalization and get your tools vendors to take privilege less and build a better security argument in the first place.
Any questions for Bill?
Curious on their processes, can you share a little bit about who's the storehouse of the best go-to process?
When you say the go-to processes, are you talking about organizational processes?
DevSecOps.
Oh, so look at Cyber.mil. They've got some nice documentation, some nice white papers that are freely downloadable, and they're doing a good job. The Air Force has certainly published some papers that are very nice. They've been working very hard on this. It's very interesting to watch Amazon and Microsoft in their competition with each other because they're taking a fundamentally different approach. Amazon gives you a container, and then they have third parties that resell layers on top of that. Like if you look at the control set, right, to get a system approved, usually you're dealing with somewhere in the 280 to 400 controls, right, depending on your level of your system. And Azure is taking a different approach. Azure is actually trying to provide a lot of those controls. That's part of what Cloud One helps do, is it tries to do more controls. If all you're getting from your cloud vendor is, you know, two-party access to the server room, they help them a lot of other stuff to fix. So, you know, what do you do? We haven't, you know, it would be nice because everybody's hand building their organizational controls over and over and over again. And it's awfully silly. And you look at CMMC, right? So they're about to push into the federal acquisition regulation, new updates to the CMMC. And they've been trying to get CMMC to have teeth. This is this cyber maturity model criteria. And our general counsel's nuts about it. He reads it all, and he you know, has these bits where he gets all the engineering managers together, and you know, we have this discussion and we talk about it. And, you know, did I mention we support 6,000 computing platforms? We thought about the impact of trying to do all the 800 171 controls for 6,000 computing platforms and every development software you can ever think of, even old versions. Oh my gosh. So now virtualization is really good in those environments, but at the same time, you're running, you know, in some cases, 10-year-old developer tools. So you know, some of the things that come on, you know, I wanted to ask, there's Rob from Microsoft, why didn't you use PowerShell instead of Bash? They have PowerShell on Linux. And with PowerShell, you can actually sign your scripts. You can't sign your Bash scripts. I'm like, not aware of. That'd be cool. Can you sign your Bash scripts to say, because, you know, your Bash scripts might do very privileged things. How do you know that it's the Bash script that you left on the system a couple of days ago? Is it the same Bash script? Maybe it changed because Fred went in and made a few changes to it and thought, you know, that was cool, and didn't realize it was the production.
Even just a rev history in your Bash scripts.
Yeah.
You know, so.
Yeah, check it into a repository.
Yeah.
But how do you know you're actually running the one that was in the repository?
At least if it were in a changelog repository, you had a means to potentially validate that, rather than right now it's last one wins.
So it's,
you know, just try and dip every single time you make a change. Right. Keep that at the log.
it's
If you
kind of like,
remember, if
That
you
would be-
remember,
I'll build it into your.
yeah, build it into the script.
Yeah, whenever I import something in a secure environment, I just run diff on it to make certain that I didn't.
so with Air Force funding, OIS had sponsored the layered assurance workshop for many years and had held this workshop. And it's about layering security up so that you can actually, the thing below you, you can depend on. We have a relationship with a firm who does bioscanning, because one of the guys at Intel who ran the chip scanning group for BIOS, and BIOS is subverted, then you're dead.
We've got some tools we're playing with for BIOS and firmware scanning.
Yeah, Cope's even does this. And anyway, there's a lot of layering here, and the question is, are you actually achieving the control objectives? You know, are you sweeping your porch in a sandstorm? You're actually achieving your control objectives, and as opposed to checking the boxes. And
Right.
that's the real trick, is to do something useful. And if you start to think about it this way, and a lot of the DevSecOps processes are at least oriented towards this, if you embrace them and don't get too caught up in the cool tools, because you can do all of these. You can do all of these properties with or without the cool tools, right? And the question is, what's the end objective? What's your surface area, right? What's your APIs? What are you exposing to what? And what's your information flow diagram? Some of those basic principles, if you design from there, then you can end up with a pattern that's repeatable and easy to get approved. And it goes back to the vendors.
Well,
Right?
also
The
goes back,
vendors have, you gotta be willing to pay your vendors more to buy additional capabilities in the tool,
Mhm.
right? So that they've actually done that work.
right,
And it has to be
you're
a
offsetting
big
that cost.
differentiator.
Well, it gets back to the earlier conversation about having agreed to terms that actually have specific meanings. So you know you're actually getting what you need to feel good about it.
Right.
Because you can talk all you want, but that's Canadian English. You know, that's a little bit different than American English. So if we have a common agreement of what that term actually means in terms of security or compliance or rigor or value,
Right.
without that common language, we're just talking.
Right. Well, and it would just be helpful if the people who acquire the IT systems had computer science backgrounds,
Crazy.
which they don't normally don't.
Yeah.
And if you look at the people who design ships and fighter aircraft, they do. They don't give the keys to the architecture to some shipboard system to somebody who's not very good at computer science. Yeah, and can smell fools. So anyway, it's, I don't know if this is useful talk, but
Great.